In this video, we'll be talking about solubility. Now, say you add some salt to a container of water. You stir it until all of the salt dissolves, and you can keep doing this until the salt concentration reaches a natural limit. Now, this limit is determined by the relative strength of the solute-solute, solute-solvent, and solvent-solvent intermolecular forces. When you reach this limit, no more salt will dissolve, no matter how hard you stir. This limit to how much you can dissolve is called the solubility of the salt in that particular liquid. We say that like dissolves like. And from a chemistry perspective, when we say like, we're talking intermolecular forces. Polar solutes tend to be soluble in polar solvents, but not in nonpolar solvents. The ability to dissolve in a polar solvent like water is related to whether the solute can form dipole-dipole interactions, or in some cases hydrogen bonding or ion dipole interactions. Nonpolar molecules tend to be soluble in nonpolar solvents, but not in polar solvents. The forces at work here are London dispersion forces. Nonpolar molecules tend to be much more attracted to themselves than they are to polar molecules like water. If a nonpolar substance like oil is mixed with water, two separate layers will form. Water is often called the universal solvent because there are more solutes that are able to dissolve in water than in any other liquid. But not all solutes can dissolve in water. A solid solute that can't dissolve in a particular solvent is said to be insoluble in that solvent. Let's talk about solubility. Solubility is a property referring to the ability of a given substance, be it solid, liquid, or gas, to dissolve in a particular solvent, which is usually a liquid, and to form a solution. Solubility is measured in terms of the maximum amount of solute that can be dissolved in a solvent at equilibrium. In other words, the maximum concentration that can be achieved. When a solute's concentration is equal to its solubility, the solution is said to be saturated with that solute. And you will not be able to dissolve any more of the solute in the solvent without it precipitating out. If the solute's concentration is less than its solubility, it's said to be unsaturated. Now, it is possible to make a solution where the solute concentration exceeds the solubility, and we call these solutions supersaturated. And we'll talk about how to make one of these in a moment. A solution with low concentration of solute is called dilute, and a solution with high concentration of solute is called concentrated. Solubility can be affected by temperature. When you increase the kinetic energy, this allows the solvent molecules to more effectively break apart the solute molecules, or ionic compounds, that are held together by intermolecular attractions. In this graph, we can see that the solubility for many compounds increases as you increase the temperature. Now, this does not happen in all cases. If you look at that line at the bottom, you can see the solubility for cerium-3 sulfate actually decreases as you increase the temperature. We can take advantage of this to make supersaturated solutions. And the way we do this is we prepare a solution at high temperature where the solute is more soluble, and then we cool it to a lower temperature without precipitating the solute. And we can precipitate the excess solute by adding a seed crystal or by mechanically agitating, which is a fancy word for stirring. And then all of a sudden, things start to precipitate out. When we're talking about liquid-liquid solutions, we often talk about miscibility. When two polar liquids are mixed, they completely blend and dissolve into one another. And when nonpolar liquids are mixed, they will dissolve into each other as well. Liquids that dissolve in one another in any proportion, this means any ratio, are said to be miscible. Miscible liquids generally mix without any limit. Solubility is a more general term that applies to just about any state, but miscibility is a term that we only use when we're talking about liquids. When we talk about the solubility of a solid, there tends to be a limit to how much we can dissolve. However, miscible liquids are generally mixable at all amounts, and there's no limit. And miscibility, just like other types of solubility, relies on intermolecular forces. Here's an example of ethanol dissolving in water. Notice that ethanol is capable of forming hydrogen bonds, and those intermolecular attractions make dissolving very favorable. You can also get miscibility with a nonpolar solute and a nonpolar solvent. One important thing to note, if you mix two liquids that are miscible, the volumes may not add up. Adding ethyl alcohol to water is a common example. The volume that you end up with is not necessarily the same as the volume that you started with. It is usually less. That's because these substances are miscible in each other. Nonpolar liquids generally do not dissolve in polar liquids and vice versa. Substances that do not dissolve in one another are said to be immiscible. The particles are more attracted to themselves than to the solvent. Molecular size can also influence the solubility and/or miscibility of a substance. For example, even though it can form hydrogen bonds, hexanol is not miscible in water. The long nonpolar part of it limits its solubility. Gases can dissolve in liquids and form solutions. Oxygen dissolves in water to form a solution of water and oxygen gas. Dipole-induced dipole forces allow it to do this. And this phenomenon is extremely important for aquatic life. Gases can dissolve in other gases to form solutions. Gases are generally infinitely soluble in one another. Air is an example of a gas-gas solution. Now let's talk about how ionic compounds like salts dissolve in water. Water molecules move around with a lot of kinetic energy, and the partial negative charge of the oxygen on the water molecules is attracted to the positively charged ions in the ionic crystal lattice. Likewise, the partial positive charges on the hydrogen atoms in the water molecule are attracted to the negative ions in the ionic crystal lattice. The moving, attracting water molecules pull the crystal lattice apart, and we call this process of cations and anions separating from their ionic crystal lattice dissociation. Individual ions are then surrounded by solvent particles in a process called solvation, and when the solvent is water, we call this process hydration. Now let's talk about how molecular compounds like sugar dissolve. When water dissolves sugar, it separates the molecules by disrupting the attractive forces, but it does not break the molecules into its atoms. The water molecules arrange themselves around the sugar molecules, but it's not as organized as it is with salt. Sugar molecules contain many OH groups that can form hydrogen bonds with the water, and this is one of the reasons that sugar dissolves so well. So let's summarize. Substances with similar intermolecular attractions tend to be miscible or soluble in one another. Polar substances tend to be soluble in polar substances, and nonpolar substances tend to be soluble in nonpolar substances. Solubility is a measure of the maximum amount of solute that can be dissolved in a solvent. Solubility can be affected by temperature, and the term miscibility refers to the ability of a liquid solute to dissolve in a liquid